Okay, we have spent a couple of weeks talking about functions in general. Now we're going to spend some time looking at some very specific functions, and that would be linear functions. And if you'll recall, linear functions are what? Functions whose graph is a line. Okay, and what we're going to do today is we're going to graph linear functions. So graph lines, and we are going to use, let me get that right there, we are going to use tables. We're going to learn several ways to graph lines. This is probably going to be the least favorite way, but it's something we need to look at. So we're going to graph lines using tables. Now, first of all, we need to be able to tell whether an ordered pair, and an ordered pair is a point, we're going to tell if it's a solution of an equation. The deal with linear equations is they will often have two variables, an x and a y, because if you have a graph and if you have a line on that graph, each point on the line, right, has an x-coordinate and a y-coordinate. So that is why linear equations most often have an x and a y. Now, a solution, what does solution mean? Solution means when something's a solution, it makes an equation true. Okay, so what we're going to look at, they're going to give us a linear equation. It's got an x, it's got a y. We'll talk more as we go along about how we know that's a linear equation, and they're going to give us a point. And we're going to see if this point is a solution. Well, we know the first value is the x-coordinate, the second value is the y-coordinate. So we're going to plug these ordered pairs in. We're going to say 3 times -1. We're going to put -1 in for x, minus 2 times y is 1, so we're going to substitute that, and we're asking, does that equal -5? All right, order of operations. 3 times -1 is -3, minus 2 times 1 is 2. We want to know, does that equal -5? -3 minus 2 is in fact -5. This is equal. Since it makes this true, we would say yes. That ordered pair is a solution. Most of the time you're just going to write yes or no, and that's fine, but for your notes put it is a solution. All right, now, second problem. They give you a linear equation. They give you an ordered pair. I want you to pause the video and see if this ordered pair is a solution to that equation. Did you get no? I had -7 times -3. That gave me a positive 21. Here, I've got a -4. Right here is what I mean. And a -5, that negative times a negative gives me a plus 20. 21 plus 20 is 41, and that does not equal, notice I put the slash through the does not equal, 1. I also want to point out, I neglected to say this a minute ago, when I put this little question mark above an equal sign, that means I'm asking, is it equal? I don't know yet till I get to the very end. So that's how you determine if a point or an ordered pair is a solution of an equation. All right, now we're going to actually start graphing. They're going to give us a linear equation, and here they gave us the equation y equals 1/2 x, and they've given us a domain of 0, 2, 4, 6, and 8. What is the domain? Domain are your x values, right? So the way we're going to graph, we're going to make a 3-column table. We're going to make a column for x. We're going to make a column for our rule. Our rule here is 1/2 x. And we're going to make a column for y, because we're going to plug these x values in and find our y values. This is like function notation. We're plugging x in to find our y values. They gave us 5 specific values, 0, 2, 4, 6, and 8. We're going to plug those into the function. When x is 0, we get half of 0, which is 0. Y is 0. We just found the point, 0, 0. When x is 2, half of 2 is 1. So we just found the point, 2, 1. When x is 4, half of 4, we plug it in, we get 2. So we just found the point for 2. Half of 6 is 3. And half of 8 is 4. So we found these points. Notice that each time they follow the rule. Y, let's look down here. Y is half of x every time. Y is half of x every time. We also found the range. What is the range of this function? Remember, the range is your y values. So we could say that the range for this function, we do the little squiggly brackets, are 0, 1, 2, 3, and 4. Now they want us to graph it. Now notice we've got sort of a small graph over here. Like we can't get to 8 on the x-axis, I don't think. 1, 2, 3, 4, 5, 6. We can't. So we're going to have to count by something other than 1. So I'm going to count by 2s. 2, 4, 6, 8, 10. I'm going to count by 2s on my x-axis. And then my y-axis, I think I can count by 1. So I'm going to do 1, 2, 3, 4, 5. I'm doing every other one just because I don't have a lot of room. I'm going to plot these points. 0, 0, 2, 1, 4, 2, 6, 3. Make sure you pay attention to your scale. And 8, 4. So I plotted those points, and I'm not going to connect them. And the reason I'm not going to connect them is they gave me specific values for the domain. These are my domain values, so that's all I plugged in. Those are the only points I have. Okay? Now, here's a little bit different one. Y equals 2x minus 1. They give you the domain. I want you to make the table, so I want you to have a table like this, and then I want you to graph it. Pause the video, try that out, and then turn it on and check it. Okay, notice a couple things. Notice I had to change my scale on the y-axis because it wouldn't fit if I counted by ones. What else was I going to point out? Notice that these are both linear, okay? We could connect them. If we were to connect them, they would be aligned. But since they gave us specific x values, they gave us the domain, that's all they wanted us to use, so those are the only points that we put on the graph. Also notice that both of these are increasing, okay? Be looking for things like that that we've talked about before. It all stays together. It will all follow us from here on out. All right, let's look at what's next. Okay, this looks a lot like what we just started with. They give us a linear equation, y equals 2x plus 2. But the difference for this is they don't give us specific x values. We get to choose our our x values. We get to choose any x we want. They're telling us that anything's in the domain, okay? So, we're going to make our table, and we get to choose x values. Now, here's what we're going to do. We need at least 2 points to make a line. You got to have 2 points. Most teachers will want you to have 3 just to check yourself. We're going to do 4 just for funsies. All right, we're going to make one of them negative because we need some practice with our integer rules. So let's do -1. We like 0. We're going to use 0 a lot. It makes things disappear. We like 1 because it's also easy to work with, and we'll do 2 just because it's not too bad either. So we're going to plug these values in. 2 times -1 is -2 plus 2 is 0. 2 times 0 plus 2 is 2. 2 times 1 plus 2 is 4. And 2 times 2 plus 2 is 6. Okay? So, what happens when we graph these? Well, these all fit. Does this go to 6? It does. I don't think we have to change our scale. So, -1, 0 is a point there. 0, 2 is there. 1, 4 is there. And 2, 6 is there. Notice they're linear. Since we weren't told specific x values, this is when we want to connect. We're going to draw a line through the points, okay? Now that's not a great line, but go all the way through the points, put arrows on both ends. That's showing that that line goes forever. And every line has a name. And no, the name is not Bob. You're going to take the equation and you're going to write it on the line. And that's its name. This line's name is y equals 2x plus 2. That right there looks a little bit too much like an x for me. Y equals 2x plus 2 is the name of that line. We connected it because they didn't give us a specific domain, which means we could have used any x. We just chose some that we wanted to choose. All right, one more. Y equals negative 1/2 x plus 4. They have not given us a domain, so we get to choose our x values. Now, we could choose any x values we wanted, but we want to be nice to ourselves, okay? I'm going to choose 0 every time, well, most every time, because it's going to make things disappear. Now, think about if we're taking half of something, what kind of values could we choose and make our fraction disappear? What if we chose 2? Can we take half of 2 and not have a fraction anymore? Can we take half of 4 and not have a fraction anymore? And then I'm going to throw a negative in there. What about half of negative 2? We can do that pretty easy, right? Notice my denominator was 2, and I chose even numbers so that that would cancel. So I want you to plug these values in, plug them into this equation, see what you get for y. Graph it, then turn the video back on, and let's see how you did. Okay, there you go. Now, how'd you do with the fraction and the signs? Notice here, negative 1/2 times negative 2, that would be a positive 1. 1 plus 4 gave me 5. Half of 0, even negative, is still 0. 0 plus 4 is 4. Here I'd have negative 1. 1/2 times 2 is 1, and it's got to be negative. Negative 1 plus 4 was 3. Negative 1/2 times 4, negative 2. Negative 2 plus 4 gave me 2. Remember, notice I went through the points. I put arrows on both ends. I gave it a name. Notice that this function is decreasing, right? It's going down from left to right. That's important. That will come up later. All right, if you have questions about these tables or anything we did, write them here, and we will work with linear functions and tables in class.